All right, have some cookies. All right, what do you want to do really? Arlene, have some cookie. Okay, because the exam is coming, you'd be in good mood. It's some sugar rush, okay? Uh, you guys are seeing it, right? What is going on? Okay, so first of all, you guys remember those equation where v is a function of a and t, s is a function of v and t, right? And finally, s is a function of a and t. The same way you can be doing like all those equations, right? I would say review that. I'm not going to do it now. You have done it already. Review chapter 12. Okay. All equations at least, right? All those equations like constant acceleration, okay? You would be needing all of them. All right. So that chapter 12. So whatever happened based on last exam or exam 1, review everything you would be needing it. Not necessarily I'm giving you the exam 1 questions. Okay, in exam 1 you didn't deal with forces, did you? I don't think so. In exam 2, so you'd be dealing with only forces. Okay, in exam 3 you'd be dealing with energy. Remember the energy thing that you did? And exam 3, the topics I already covered. You're doing the homework now, so basically I could have do like exam 2 and 3 together, but I'm not going to do that. So exam 3 will be like 2 weeks from this week. So this is week 9, right? So 11 12, so 12 Friday exam 3 will be, and the syllabus is already done, like the thing that we did just in last class. Remember the energy thing, right? Spring energy, remember half a cake. So all those energy things that we did, like force multiplied distance work, those things, kinetic energy, right? The equations that we use, that is exam 3. Okay, and the exam 4 topic will be collision, momentum, those sort of things. Okay, so that one would be take home only. So that's the beauty. So basically, whatever I'm going to cover from this point on, like chapter 14 is done already. So chapter 15 and anything else that I'm going to cover would be on exam, final exam, right? And that would be a take home exam. So you don't have to come in class. I'm going to give it to you on final week, and it would be due on the final week, right? Make sense? So that's the plan. And exam 2 and 3 would be similarly like what you have seen in exam 1, which is like half of it is in class, half of it will be part take home. Okay, so in class exam 2 you'd be seeing 2 questions. Out of those 2 questions, one of the question is very similar to the one that you are seeing it here. So this class, that's why very important. Everyone understand, right? So let's try to focus on this question. Any questions so far? Everyone understand? As a quick wrap up, you really need to know all those equations that happen in exam 1. So you do review them, okay? And in exam 2, you'll be seeing 4 questions, 2 in class, 2 at take home. All of them are related with force. Somewhere, somehow you have to find the force. No work, no energy involved anyway, right? Exam 3 is work and energy. Okay. I guess that's enough. Everyone's ready? Okay, let me restart reading through the problem. So if this external load P is 500 Newton and the coefficient of kinetic friction between the 50 kg crate and the inclined plane is mu k, which is this. At this plane, okay, this F or friction force is mu k n, right? Where this n is the normal force. You know that already, right? Okay, and the block does itself has a weight, okay, 50 kg, so it does have a weight which is mg. So immediately you know all the forces involved, right? You know this angle here, and this angle can be represented, right? you know this angle is 30 degree as well, right? We have talked about it so many times, so you know those, right? All right, so then let's see. Determine the velocity of the crate after it travels 6 meters up to the plane. So you gotta find the velocity, final velocity, obviously, right after it travels 6 meters. So let's start with the givens. So the first given is the mass of the crate is given 50 kg. The mu k, or the coefficient of kinetic friction, is given as 0.25. B is the external force, is given as 500 Newton. Okay, and then the final position, or S, is given as 6 meter, and initial position as 0 is 0, right? 0 meter. Okay, so think this way. So in other words, this block is moving from here to here. So if this is S0 equal to 0, right? And this distance from here to here is S equal to 6 meter. And obviously this does have the angle, right? You got it so far? Perfect. All right, moving on. So now let me draw a sketch, the real sketch. Okay, so the sketch would be with the block, a free body diagram. Okay, you know the normal force acting always perpendicular to the surface, and you have this external force P given as 500 Newton, right? And you have this weight acting downward. That's the weight. Now obviously this weight is mg, you know this. And this weight does have two components, right? One component comes with along the n direction, right? And another component comes with along the plane of travel. Okay, so that one would be W. If this is 30 degree, that one would be W sine theta, sine 30 in the other case, and this one would be W cos 30, right? You got it so far? All right, perfect. And then you have this P does have different component as well, right? This P has both x and y component. Assume this is in x direction, right? So this should be P cos 30, and this should be P sine 30. You got it? All right, obviously you have this friction force acting opposite to the travel. So this is friction force. Okay, and then you can start to write the value of those forces. So P is 500 Newton given, right? I already wrote it over there. And this W equal to mg. What is this m? 59.81. This is in Newton. Okay. So then this friction force F would be mu k n. Okay. So this would be 0.25 n. Now, because this n is for Newton, you would like to put a code on the top of n. That's why that's how you're gonna make a difference. So this is normal force. So this is Newton. This is normal force. This is normal force. This could be in Newton, right? So this n prime is normal force. And n here is the unit for Newton. Okay, so let me write it here. So this is Newton. So few equations, b square, b0 square, 2a. Okay. Now that we have kind of everything sorted out, our ultimate goal is to find the velocity, right? To find the velocity, what we can do is we can use this equation from previous chapter, okay? We can use this equation plug the value of acceleration, plug the value of this position, initial and final position, and find the velocity of the b. Does it make sense? You remember that equation we learned it in last exam 1. Final velocity square equal to initial velocity square plus 2a, the distance traveled, right? A is the acceleration in this case. You got it? Remember that one from the last exam? So that's the equation you would be using here, okay, to find the velocity. But here's the catch. So how to find the acceleration? The acceleration is not nowhere given, right? How to find it? We have all the forces, and this block is moving. This is dynamics class, right? The block is moving, right? So if the block is moving up because of the external force and everything, so it does have acceleration, right? Remember? So summation of fx would be in x. This is the x direction. Able to see that? This is the x direction. Summation of the forces in x direction should be equal to the mass of this body multiplied the acceleration of this body that it is moving. Make sense? Make sense? So again, summation of the force in x direction, right? Summation of the force in x direction should be equal to mass of this body multiplied the acceleration of this body that is moving. Understand? So think this way. Say like this is moving in x direction, right? So now I'm pushing it, so I'm pulling it now. So there is the external force, right? Just very similar to that. So there is the friction force, right? Because of the normal force, there's a friction force opposite to this direction, right? So two forces acting on this block, right? Along with the weight of this body, right? So all those forces acting along the x direction. Now this is a horizontal plane, but if it is inclined, this will be much more interesting, right? So then you have this. You see, if it's inclined, this glass is about to fall, right? And it's falling down. So if I have external force acting up, right? What it's doing? The external force does have its component. One in x direction, this direction, the plane. Another one is in the vertical direction. Make sense? You got it? Okay. Same way, this weight, this glass weight has two directions, right? So one is this x direction, other one is the vertical direction along with that, right? That's what I draw here. Bottom line, what I'm trying to say here, see, this glass, when it is in the inclined plane, I'm pulling it up. It has a resultant acceleration, right? Because it's moving up. This makes sense? So if you can find that acceleration somehow, then you can plug this in this equation to find the velocity. And is that what we are after, right? Everybody? Okay, so now that's about the x direction force. What about the y direction force? Is the block is moving in y direction? No, the block is not moving in y direction. That means it just has three components actually. It has this normal component of the force. Okay, it has this p component of the force, one of that's acting up, and it has this w component of the force that is acting down, right? In vertical direction. That's it. So why we're dealing with the y direction? Just to find the value of the n. Why need the n? Because we're going to plug the n value to find the friction force, and we're going to use it in x direction. Okay? Strategy understand. We're going to do summation of fx, summation of fy. We're going to find the n value in summation of fy, right? You know, once we have that n value, we're going to use it in summation of fx, where we have the a in the right side, right? Acceleration. We're going to find the a or acceleration. We're going to plug that value of the a here in this equation to find the final velocity, where we know the initial velocity is 0, we know the s values, right? S and S0. Do you understand? Do it. I'm going to give you the answer, so why don't you do it? Have some cookies, have some sugar rush, and do the problem. Okay, so you're going to have, let me give you some values. So the strategy, okay, so this is the solution. This is part of the exam review project. Okay, so exam is on Friday. It has 2 parts. In class exam, you're going to have something very similar what you're doing here. Okay, so out of 2 problems, 1 problem, something very similar that you're doing. So very important. Try your best to finish it by yourself. Okay, so you have the equation of motion. You'll be writing it. So we'll have 4 exams. I already announced everything. Okay, and it's in record. So watch the video lecture. Equation of motion. So you do have 2 of them. Okay, so you have summation of Fy equal MAY. Okay, and you know y direction no movement, right? And you can actually do one thing. You can put a x prime, and you can put a y prime here. Why? Because this is not usual x and y. It has an angle. That's why. All right. So yeah, and then obviously you would like to start putting the equations on the left side, and right side it would be 0, right? So you have these three terms. I'm putting three fill in the blanks, right? 1 plus 1 minus. So see if you can fill in the blanks here. You'll need more space, by the way. So 3 fill in the blanks. So plus, minus, it would be 0, right? And you would be finding from this, after you're doing all the computation, all those fancy stuff, you're gonna finding this n prime 174 Newton. Okay, that would be first part. The second part, you'd be doing summation of fx prime equal max prime, right? This ax prime is what you are after, by the way. So then you have again fill in the blanks, three things. 1 plus 2 minus 3 equal max prime. And after doing all those tedious work, you should be finding the ax prime value is 7.79 meter per second square. Okay, and finally you're going to use it in this equation. Remember, the final velocity equal initial velocity plus 2 multiplied these distances, initial and final distance, multiply this ax prime. Okay, and from there, you know, this is 0, this is 0. You're going to plug the other values, right? And then you're going to find the value of the velocity, and the velocity value would become 9.7 meter per second. All right, I think that should be enough to deal with this problem. See how comfortable you are. Whenever you are done, get all those values, you just show it to me, and then I'm gonna say like, go. And this is just one of the sample in exam. Like this kind of problem is going to come in exam, where you only have to explore the forces, right? You have to do equation of motion all the time. You might have to find the acceleration, you might have to find the velocity, you might have to find the position, you might have to do the integration for that. You know, so many things can. I mean, in class you may not have to do integration, okay? But in take home part you may, okay? Just trying to give you a heads up. So everybody wants to finish it by yourself. Fill in the blanks, do the math, come up with the result, n prime. What is n prime again? The normal force. Once you have the n prime value, you're going to plug it here, right? To this F equation, FF, F is the friction force, right? And fill in the blanks here, find the value of the AX, right? Once you have that, then plug the AX value here in this equation, find the value of the final velocity. Arlene, you got it? You need some help? You gotta do some work, man. Okay? Alright. So then the video is on record. Watch the video when you're feeling good, okay? Just try to understand as much as you can. Did you know you're good? Do you have any question? Oh. Let me know.
I do have talk to you about the trial, but it's just scheduling for the.
I understand. They don't have that.
Yeah, well, because I only have 3:15 and 3:30, and they end around 4, so I only have like 45 minutes.
No, you had to try. Right. You have to.
No, well, no, wait, actually.
You can do that.
I have
You don't need to go there.
I have a calculus class or calculus quiz on around 9. I don't know when I will finish, but I think I'll probably be able to get out in time, maybe.
If you can come at 2, right?
See if I can.
Oh, and I'm here. You don't need to go.
Yeah, okay, so I come here at three. I stay here till five. Okay.
If this class is busy after 4, then you could go to the office or someplace else. Or in the library. You go in the library. This class is busy. But between the 5, after 5, you know how to stay, right?
Yeah, I can stand that.
You stay and listen.
Okay.
How you guys are doing? Fill in the blanks, come up. Okay, let me start to give some info, right? How about the first one? On the first one, you should be putting things on the fill in the blanks. These three forces, right? So you should have like this n prime, right? This n prime plus p sine 30 minus w cos 30. Is that what you guys got? Perfect. Okay, let me put some values here for the other one. You should have minus ff, there's the friction force, plus p cos 30 minus w sine 30. Now what is this p cos 30, p sine 30, w cos 30, w sine 30? It's all in the free body diagram. You see that, right? So they're like this. P has an angle of 30, so it should have two components as well in x and y direction. The same thing is for the w. W is acting with a 30-degree angle. You should have two components in x and y direction, right? So that's the reason you have like these four components for these two forces, right? P and w. And along with that, you have this n prime and f. Those are usually related by this mu. Okay. So obviously, left part, let me start to finish. So n prime would become w cos 30 minus p sine 30. And then you're going to start to plug the values. So w is 50 multiplied 9.81 multiplied cos 30 minus p is 500 sine 30, and then this whole thing is in Newton. Okay, and that is your n prime. And here obviously you have this minus mu k n prime plus this p cos 30 minus mg sine 30 multiplied max prime. Okay, and then you're going to start to plug all the values, right? So this ax prime will become, so you have this m in the denominator, in the numerator you have minus mu k n prime plus p cos 30 minus mg sine 30. Okay, and then let me move it. So you're gonna have ax prime equal, start to plug the values, minus 0.25 multiplied 174 plus 500 cos 30 minus 50 multiplied 9.81 sine 30 divided by 50. Okay, the whole thing would be meter per second square. Should be doing the math to find this value.
When I do that, I get 2.88.
I have 7.79. Is that the value we got?
I got 2.88 as well.
Okay, so do you have the value of n prime 174?
Yeah.
Okay, so that means I might have a calculation error. Let me verify. So you have a negative 59.81 sine 30 plus 500 cos 30 minus 0.25. Did you check whether the angle is in radians or in degree?
Mine's in degrees.
Okay, so all right, let me check on other place. Okay, so ax. Okay. I'm not seeing any error on my equation writing. So that means the calculation only. How many of you got 2 point what you said? All of you? I have a mistake then, definitely. Sorry. So it should be what, like 2.88? And when we're gonna plug the values here, so this V should be equal 2 multiplied S multiplied AX, and then so 2 multiplied, what is the value of the S? 6, 2.88 meter per second. What is the value of V you guys got?
3.86.
Everybody getting the same value? Then that is the answer. So again, to give you an overview of this problem, we are given with a block with the external force P of 500 Newton acting with an angle 30 degree, with the inclined plane another 30 degree. Right? Okay, so what we did on this problem, we had to do the equation of motion in both x and y direction. Obviously, plane direction is x direction and vertical to plane direction is y direction. We use the x prime and y prime because those are not usual x and y direction. All right, so x prime and y prime is for that reason. And obviously, to find the friction force, we need the normal force. That's the reason we use this y direction equation of motion. We know there is no movement of y direction on the block itself, so we'll find the n prime by simply counting all the forces acting on y direction. And then once you have the value of n prime, we have the friction force from this mu k n prime. And once we had that, then we use the equation of motion in x prime direction. We had all the forces in left side, and the right side we have this mass multiplied acceleration, which the acceleration is obviously the actual movement of the block in x prime direction. And
The V he got was a little off. He just plugged it in wrong.
Yeah.
So I got around 6, yeah.
But
it's I'll update it. The result is not a matter. The technique is all that matter. Once you have the prime, and then we just simply apply it with the V equation where the initial velocity is 0, the initial position is 0 as well. We only need the values of acceleration, the final velocity, so acceleration, the final position, okay, and then you can find the final velocity. And that's the problem. So the value of the V, Alicia, what did you get?
I got 5.88.
So we have so many opinions. So 5 point what?
88.
Is that what everybody found?
Yeah, that's
Okay, so I take it. I take it as good. All right, so you see, then, exam 2, let's recap. Got with the problem, I did already. So exam 2, 4 problems, 2 in class, 2 part. Okay. So in class 1, one of the problems is very similar to that. So be very serious. Do one time at least before coming to class. So the other problem would be again easier one, because in class I like to give you so easy, so you relax and do it in your own time, okay, with peace in mind. Okay. So that's the idea about in class. The take home would be challenging. Let me give you a heads up. So you'll be seeing the integration all over the places. We did so many integration in class, right? In homeworks, in all the places. So you should be dealing with the integration. There's no way around. Okay. And 2 problems. And in class would be due, and you'll be finding it in the bright space. It would be due on Monday next week. Okay. And the take home would be due on classes. I'm sorry. In class would be due in class. Take home would be due on Monday. I'm sorry. What I'm saying. Next week Monday. And that's exam 2. Exam 3 materials I already covered, which is the work and energy terms. Remember, I did the equations for last few days, chapter 14. So that is in exam 3, and that would be on week 11. This is week 9. Okay, week 11 would be week 11, the last day, Friday, the exam 3. And final exam would be the material that I will start to cover from on Monday. From Monday next week, I will start to cover the final exam material. Okay. And then final exam, to give you just peace in mind, the final exam will be take home. Okay, so you don't have to worry about too much stress in class, because you have like 3 exams already in class. So there's no meaning for me to give so many exams in class. So the final exam will be completely take home, and there will be challenging problem as well. Take home always, as like always. Okay. and I'll talk more about final exam when time comes. Bottom line, I'm gonna give it to you possibly at the end of the day, like week 14, day 3. Okay, and it will be due on the exam day. Make sense? On week 15, whatever the exam day will be for this class, most likely on Thursday. Yeah, I forgot now. I've seen this thing before. Okay. Any question? If not, then I'll see you. Please help yourself with the cookies. Finish the cookies. I don't want to get myself with the cookies. All right. And I'll see you on exam day.